In this case, as you can see, what's the difference? The difference is like this. There's no shielding in the first zone. Only in the second zone, there's shielding. But it goes from 0 to 2 straight away for the shielding. Because of this, the SPD need to go from 0 to 2 straight away as well. Because otherwise, zone 2, if you combine for both surges and radiated, cannot be in zone 2 as well. So because of this, we need a special SPD there. That's why the SPD there for surges, conducted surges, need to be from 0, U0, I0, straight to U2, I2. So we call it specially coordinated SPD. It means it has 2 stages that actually reduce from U0 straight to U2. Maybe you have 2 SPD there, first to reduce for the first stage, and then second for the second stage, second zone, if you like. So this is an example of application also from H0 to H2. In this case, there is no shielding for both zones, but the SPD is been defined as reducing from zone 0 to zone 2. And the equipment itself also has no shielding, but you have an extra surge arrestor before the equipment itself. So it's good. You have one at the main board, one at the switchboard, and one at the equipment itself. Before the equipment, it's like your PC. So this is another application example. So this is, as you can see here, if you're talking about zone, you have LPZ0, B, because it is not exposed to direct strike, whereas LPZ0A is exposed to direct strike because there is no protection there. But because of the air terminal, you have B there. 1 is defined as no exposure to direct strike. So this is from LPS understanding. But also LPZ1, if you have shielding from magnetic also defined as when you don't have any magnetic radiation, or not don't have any, but you reduce the magnetic radiation by some sort of shielding. As you can see there, the blue dotted line here is actually a shielding to reduce to zone 1. But for the conduction, you have wires that goes in. You can use SPDs to go to Z1, Z2, even Z3. You can see here SPD. These are the yellow one is for the signal, and the red one is actually for power lines. Okay, and you have type also there, type 1 and type 2. And usually the type 1 is actually at zone 1, and type 2 and 3 is actually at succeeding or the zone after zone 1. Okay, so this is an example. For example, Z3 there, zone 3, it could be just a cabinet where you put another SPD, like in previous example. Before the equipment, we put another SPD. So the equipment there is become Z3. Z2 is maybe the switchboard, and Z1 is actually at the main board. Okay, so this is another example to see how the structures, the location, and so on. Another one. In this slide, interconnection of LPZ of the same order may be necessary. For example, you have one structure is in zone 2. One room in a structure is zone 2, and another room inside the same structure is zone 2, and you want to interconnect them. So when you want to connect them, because they are same zone, then there should be, then they are exposed to, between them, maybe lower zone, like zone 0 or even 1 or 0. So for example, here you have zone 1 to zone 1 and exposed to zone 0. So this is the exposed line. So this exposed line means they can be exposed to direct strike. Whereas LPZ1, the house next door is Z1, the house here is also Z1. Therefore, you can use SPD at both ends to limit the surges that goes in both ways. Or instead of using SPD, you can use shielded line. And the shielded line means the line that connect between zone 1 on the left and zone 1 on the right is actually within a conduit which is also zone 1. So that's okay. That means there is no way a strike directly can happen to the line, but only to the shield of the line, as shown there. So this is between Z2 and Z2 again, but again you need, this is defined as Z1 here. So, but still Z1, you can still have what we call radiation, and it can still induce surges, even though there's no direct strike. So the surges can go to both sides, and therefore you need SPD at both ends, because those zones are zone 2. Or if you want to maintain them as zone 2, you can put a shielded line as shown here. So this is shielded line, meaning to say there is no way the magnetic field can actually be induced or can actually cause coupling of the line connecting the two because of the shielded presence there. This is a typical example of, for example, we have a structure, usually TMB, they have their transformer exposed to for example, surges. So you can put SPD at the entrance there. But sometimes the transformer is within the building. For example, KLCC. So, but the incoming line is zone 0. So you see the zone 0 is within zone 1, as you can see on the right there. Therefore, what you can do is to actually put SPD inside there, like that. Okay. So this is another example of application, if you cannot do it. This is similar to before, whereby you can put 2 SPD for zone 1 and zone 2. So that's for the first zone, second zone. Or if you want straight away at the entrance of here, straight to zone 2, okay, then you need to use a special SPD there for this one, special SPD, because it from 0 to 2. Okay, another criteria, just now we have described at the boundaries. So the boundaries, we don't describe too much on the shielding, but the zoning by search, conducted search using SPDs. So we describe how the that is being done. But the line shielding is being described as well. Now,